All right, we're going to take some notes on solving for y. Another way to say this is to put it in function form. There's actually a few other ways you can say this as well. So what I'm going to do actually is I'm going to write one of these forms out. Y equals mx plus b. And this is called slope-intercept form. Slope-intercept form. Okay, so I could say solve for y. That means get y by itself. I could say put it in function form. That would make it this form. I could say put it in slope-intercept form. That would be putting it in this form as well. The reason why you have to do this is because in all of those graphs you were previously doing with tables, the y term was by itself on the more difficult problems. So they're not always going to give us problems with y by itself. For example, we're going to do example number 1 here. I may have a problem like x plus y equals 6. Okay. Now, you can think of all those ordered pairs that add together to equal 6. That's what you were doing before. But when it gets more difficult and you can't think of the ordered pairs in your head, you're going to need to be able to get y by itself. This form right now is actually called standard form. Standard form. In standard form is ax plus by equals c. So it's saying something in front of the x plus something in front of the y equals a constant c. Well, you might say, hey, there's nothing in front of the x and y, but remember there are numbers in front of the x and y. There's a 1. So right now, a is 1, b is also 1, c is 6. And I want to get y by itself. So I'm going to remind you about how to do this with a balanced scale. So draw those balanced scales we used to draw a while ago. And on this side we have x plus y, or you can make it 1x plus 1y. And on this side we have 6. And we have to keep the scale balanced. Well, if I tell you I want y to be all by itself on a side, it's not right now. What's over there with it? 1x is over there with it. So if I have 1x, how do I get rid of 1x? I subtract 1x, so minus 1x. But if I just do that to one side, what happens to the scale? It tips, right? So I need to subtract 1x to the other side. Well, what we have left then, these x's cancel out, and what's left on the left? Just the y. So y equals, and on this side I have a constant of 6 and I have a negative 1x. They are not like terms, so I cannot put them together. I could make that plus a negative 1 or I can make it minus 1x. Since they're not like terms, they have to stay like that. They don't make 5x. They are different terms. These are apples, these are oranges. This has an x, this does not. The last thing we need to do is we need to put it in slope-intercept form, which is y equals mx plus b. So I want the mx term to come first, and right now it's coming second. So that minus sign goes with the 1x, or you could make it plus a negative 1. So when I rearrange and put this in the correct order, it becomes y equals negative 1x plus 6. The x term was still negative, and the constant, the 6, is still positive. Don't switch your signs around when you're reordering the problem. All right, so that was the first example in getting y by itself. We're going to do another example here, so scoot your paper up. Let's do example number 2. It's x plus 2y equals 6. Okay, so is it in slope-intercept form, which is y by itself? No, it's not. Well, what's happening? Two things are happening. 1x is being added to it, and the y term is also being multiplied by a 2. The y is being multiplied by 2. So we are always going to undo addition or subtraction first. So how do we get rid of 1x? We subtract 1x. Whatever I do to one side, I do to the other. So this is the same step as before. The problem is identical to the problem up above. I've just put a 2 in front of the y there. So these cancel, and I'm left with 2y equals, and I'm just going to put it in the right order right now, negative 1x plus 6. We're going to make a note off to the side here of what we just did. Always undo addition or subtraction first. Always undo addition or subtraction first. Okay? Now, the y term is by itself, but the y is not by itself. Y is being multiplied by 2. How do you undo multiply? You divide. But if you divide one side by 2, you have to divide the whole other side by 2. Every single term gets divided by 2. You can't divide one of them by 2 and not the other. So everything gets divided by 2. What is 2 divided by 2? 1, right? 2 divided by 2 equals 1. So this is a 1y, or we can just write it as y. Negative 1 divided by 2, we're going to leave that as a fraction. We want that term in front of x to be fractions. Fractions are actually going to be our friend for graphing. Trust me, you're going to be super happy later. So I'm just going to rewrite it as a negative 1/2 x. The x could be on top. It could be out to the outside. It means the same thing. And then if any fractions can be reduced, we always reduce them. And look at this one. What's 6 divided by 2? It is 3. So I have now written that in slope-intercept form. Y equals mx plus b. The m, let me write it underneath here. The m term is the negative 1/2. The b term is 3. All right, so to make our notes over on the side, we always undo addition or subtraction first. Always undo multiplication or division second. Okay? So let's practice one more. Here's number 3. All right, so it's 2x plus 4y equals 8. All right, we want y by itself. We always undo addition or subtraction first. And what are we having here? We have a plus 2x. It's a positive number in front. The opposite is minus 2x. I cancel them out. I'm left with 4y equals, these are not like terms, so I do not put them together. Minus 2x plus 8. And now I undo multiplication or division. I have multiplication, 4 times y. The opposite of multiply is divide. Everything gets divided by 4. So I have y equals negative 2 over 4. Well, that's going to be a decimal. I don't want it to be a decimal. I want it to be a fraction in simplest form. So if I write it off to the side here, negative 2/4, what does that reduce to? If you divide top and bottom by 2, that reduces to a negative 1/2. So that is a negative 1/2 x plus an 8 divided by 4. That's nice. That's a 2. We're just solving these to get y by itself. It's called function form. It's also called slope-intercept form. All right, so flip to the next page of your packet. Each one of these, you're going to have to get y by itself. Okay, so we will do number 1 together. Actually, what I'm going to do is I'm going to have you pause the video. I want you to try number 1 and then come back and see if you got it correct. Okay, your problem should already be done on the paper, and we're going to check it right now. We need to get rid of that 3x. Is 3x positive or negative? Look at the sign in front of it. It's positive. So the opposite of 3x is a negative 3x, or subtracting 3x. I know there's a minus sign in the equation, but what does that go with? It goes with the 2y. Okay, you could even make it plus a negative 2y there if you wanted. Okay, so after you do that, these cancel. The negative 2y comes down. We rewrite the negative 3x first because that's slope-intercept form, and then we write plus negative 16 or minus 16 second. They do not go together because they are not like terms. Now y is being multiplied by negative 2, so the opposite is dividing by that exact same number, negative 2. We don't divide by positive 2 or it wouldn't cancel out. A negative 2 divided by a negative 2 is a positive 1, and that's what we need in front of the y, a positive 1. So these are going to cancel out. We're going to be left with 1y, or just y. Negative 3 divided by negative 2. Can 3/2 be written as a more simplified fraction? No, it can't, but a negative divided by a negative is a positive. So that next step right there is 3/2, and the x gets rewritten. Negative divided by negative, positive 3/2. Negative 16 divided by negative 2 is a positive 8. So there we have it written in slope-intercept form. All right, so you're going to continue on with this assignment and write them all in slope-intercept form. Solve all of them for y.